So what I want to talk about now is an idea that we call reducing fractions. And the idea is this. We take a look at, say, these are pizzas that are cut into these different numbers of slices. Let me do this. Each of these images represents half a pizza. So this is a half. This is a half. And this is a half. They all represent the same amount. But look at how we describe it. This is one slice out of two, because one is half of two. This is two slices out of a total of four, because two is half of four. And this is 1, 2, 3, 4 slices out of a total of 8, because 4 is half of 8. So here's the thing. When we talk about a half, we can mean all kinds of different fractions. 1 over 2, 2 over 4, 4 over 8. So how do we do this so we can simplify it? When we talk about a half, how should we represent that amount? Should we use 4 out of 8, 2 over 4, 1 over 2? And depending on the use of your math, you might want to use 4 out of 8. That might be more meaningful for someone. But oftentimes when we're talking more generally, we want to use the simplest fraction to describe a half. So instead of 4 over 8, 2 over 4, let's use 1 over 2. Okay. So how can we turn these other fractions into 1 over 2? Now, we might just memorize it. We might say, well, 4 over 8 is a half, and I know the simplest version of a half is 1 over 2, so I'm just going to use 1 over 2. But let's say you're not sure what the simplest version of a fraction is. How do you find it if you don't know? For example, what's the simplest version of, say, 8 over 12? Is that the simplest version of that fraction? Is there maybe a version that's simpler? This is the idea with reducing. So let's take a look. Let's go with 4 over 8. Now we know the simplest version is 1 over 2. How could we turn this into a 1 and turn this into a 2 somehow? Some sort of trick that will work for this fraction, but could also work for others. Well, let me show you. If we divide the top by 4 and the bottom by 4, we divide top and bottom by the same number. 4 divided by 4 is 1. 8 divided by 4 is 2. And that gives us the 1 over 2. So here's the thing with reducing fractions. We want to divide the top and bottom by the same number, if we can. And we want to make sure that when we use this number, when we divide by it, we're not going to get remainders. We don't want remainders. If we're going to get a remainder, then we're not going to try to divide by that number. So if we try to divide, say, by 3, 4 divided by 3 would give us a remainder. So we're not going to try to use 3 as our number. Well, let's go back to this one. What can we do with this? Is there a number that divides into 8 without a remainder? but we'll also divide in the 12 without a remainder. It's got to be the same number for 8, same number for 12. Well, there is, again, it's 4. And we always need to divide by that same number. So 8 divided by 4 is 2. 12 divided by 4 is 3. And there we go. This is the simplest fraction. Now, how do I know it's the simplest? Well, let me show you something. Sometimes when we divide, we don't get the simplest fraction automatically. So suppose we have something like this. What's a number that will go into 6 without a remainder, and at the same time it could go into 30 without a remainder? Well, these are both even numbers. So the number 2, well, number 3 would work also. But because they're even numbers, I know that 2 goes into both of them evenly. So 6 divided by 2 is 3. 30 divided by 2 is 15. But it turns out this is not the simplest one. I can go a step further. I can divide both of these again by the number 3 without any remainders. So 3 goes in, divided by 3 is 1. 15 divided by 3 is 5. That's my answer. So sometimes I have to divide multiple times before I finally get my most reduced answer. And then how do I know? Well, is there a number that I can divide into 1 without a remainder that also divides into 5 without a remainder? I mean, you can't divide it by 2. It's not going to work. You could divide by 1, but 1 doesn't really count. I mean, you could do this. I mean, it counts, but it's just not going to change anything. 1 divided by 1 is 1. 5 divided by 1 is 5. You just get the same answer. If you get a fraction where the only number that goes into each of these, the top and the bottom, without creating a remainder or giving you a decimal, like if you divide 1 by 2, you're going to get 0.5. If the only number that'll work is 1, then you found the most reduced version of that fraction. All right. So that's reducing fractions. There's another way you can do this, and I'll show you in another method. It's what I call the cancellation method, and we'll do that in the next video.